Hi all. Today we will discuss about microservice architecture with three basic services like user service, order service, and payment service. User service manages user related data like user profiles, accounts, details, etc. Order service handles everything related to the creating and managing orders. And payment service, it deals with payments for the orders placed. Now, as per the diagram, we can see the user sends a request to the order service to make an order. Once the order is created, the order service needs to trigger a payment process so that it sends a message to the payment service to handle the payment. Since we want these updates to be fast and efficient, the communication between the order service and payment service is done using Apache Kafka. Apache Kafka ensures that the messages between the services are handled quickly and reliably. Next, the payment service needs to verify who the user is before processing the payment. To do that, it makes an API call to the user service to fetch user details like payment methods, account status, etc. After the payment is processed, the order service receives the final confirmation, which includes information from the user service and payment service. Finally, we have all the data needed to show the user the complete order details, including order status, payment information, and relevant user data. This kind of architecture allows each service to operate independently, communicate effectively using Kafka, and ensures that each services focus on its specific responsibility. This improves scalability and makes the system more resilient to failures, as each service can be updated or maintained without affecting the others. Now let's see how this microservice architecture works in a Eureka setup. We have introduced the Eureka Server into our existing architecture, which consists of three microservices: user service, order service, and payment service. When using Eureka, these services can automatically register themselves with the Eureka Server, making it easier for the services to discover each other without hard coding the endpoints. Here is how it works. In the registry, we have three services: user service, order service, and payment service automatically registered themselves when they start up. Other services can query the Eureka server to discover the address of any registered service without knowing its exact URL. To understand it better, let's see what Eureka is. Eureka is a part of Netflix open source tool and is widely used in Spring Cloud projects. It helps Spring-based applications register themselves, discover other services, and handle load balancing. Eureka uses a ribbon behind the scenes to manage load balancing between services. Eureka has two main parts: the Eureka Server and the Eureka Clients. The Eureka Server is a registry where all microservices register themselves. Each service provides its identity and the URLs where it can be accessed. Second part is Eureka Client. This is used by microservices to register themselves and by other services to discover available services. When a microservice starts up, it connects to the Eureka server and registers itself with the service details. The service then sends the heartbeat signal or ping every 30 seconds to keep its registration active. If a service stops sending heartbeats, it gets removed from the registry. Instead of constantly reaching out to Eureka server, Eureka clients cache the registry information locally. This allows them to find other services without contacting the server every time. The cache is updated every 30 seconds to keep it in sync with the latest information from the Eureka server. When a server needs to call another service, the Eureka client provides a list of available instances for that service. Eureka is also zone aware. It prefers to connect services that are running in the same zone, if possible. Ribbon helps with the load balancing between those available instances. The Eureka client and server communication using simple REST APIs and JSON data. So let's see how it all of this setup works with the new Eureka Server introduction. User places an order. The order service receives a request. Order service needs to communicate to the payment service for processing. It queries the Eureka server to get the latest instance of payment service instead of using hard-coded URLs in the previous, which we have in the previous diagrams. Once the payment is processed, the payment service queries the Eureka server to find the user service and fetch user detail. And finally, after all the services complete their work, the order service returns the final result with the combined data from all the services. In this setup, Eureka simplifies and manages service discovery, making the architecture more flexible, scalable, and reliable. Here we can see that Eureka solves the problems such as if there is no scaling up, if there is a dependency of environment, and change in the URLs. It uses three ways to find that. Dynamic discovery of services. Services don't need to know the exact address of each other. They can simply query the Eureka server, which provides the current address of any registered service. Second feature is automatic scaling support. If a service scales up or down, example, more instances of user services are added or order services are added, Eureka keeps track of the changes automatically. Finally, it is fault tolerant as well. If a service goes down, Eureka automatically removes it from the registry, so other services don't try to communicate with a non-functional service. That's all for this theory video. Let's connect in the next video for practical of all the things which we have discussed. Thanks.